In question number 31, a transmitting antenna is at a height of 40 meter, that is HT is 40 meter, and a receiving antenna is at a height of 60 meter. We want to find the maximum distance between them for satisfactory communication. The maximum distance is given by under root 2r ht plus under root 2r hr. Here r is the radius of earth. So dm will be 2 into 64 into 10 power 5 into height of transmitting antenna 40 plus under root 2 into 64 and height of receiving antenna 60. Simplify this, we will get maximum distance, that is 50 kilometer. So option 3 is correct option. In question number 32, in a shortwave communication, waves of which of the following frequencies will be reflected back, given the electron density of ionosphere N is 10 power 11 per meter cube. Here the cutoff frequency Fc is approximately 9 into n power 1 by 2. So Fc is equals to 9 into n is 10 power 11 power 1 by 2. This will be equal to 2.84 megahertz. So the frequency having value less than Fc will get reflected. So among the given option, 2 megahertz is less than 2.84 megahertz. So option 1 is correct option. In question number 33, a number of sine waves with modulation indices n1, n2, n3 and so on modulate a carrier waves. We want to find the total modulation index. The modulation index is given by amplitude of modulating wave divided by amplitude of carrier wave. Here carrier wave is same, so AC will be same. We can write N1 is equals to AM1 by AC, N2 is equals to AM2 by AC, N3 is equals to AM3 by AC, and so on. The net modulation index can be given by AM net divided by AC. That will be under root AM1 square by AC square plus AM2 square by AC square and so on. So this will be N1 square plus N2 square plus N3 square and so on. So option 3 is correct option. In question number 34, we want to find the maximum acceptance angle at the air core interface of an optical fiber, given N1 and N2 are the refractive indices of core and cladding respectively. Here we want to find acceptance angle for air core interface, that means this medium is air. So refractive index of this medium will be 1. Acceptance angle is the minimum angle of entrance at which, if light is incident in the optical fiber, it will be incident at critical angle at this core cladding interface. So this angle of incidence will be theta c, that is critical angle for this N1 and N2 interface. If this angle is 90, then this angle will be 90 minus theta c. The critical angle for this can be written as N1 sine theta c is equals to N2 sine refractive angle will be 90 degree. So sine theta c is equals to n2 by n1. Now, applying Snell's law at this air core interface, we can write n0 sine alpha is equals to n1 sine 90 minus theta c, but n0 is 1, so we can write sine alpha is equals to n1 sine 90 minus theta c, that will be cos theta c. So sine alpha is equals to n1 under root cos theta c can be written as 1 minus sine square theta c. So sine alpha is equals to n1 into under root sine theta c is n2 by n1, so 1 minus n2 square by n1 square. Simplify this, we will get sine alpha is equals to under root n1 square minus n2 square. So option 2 is correct option. In question number 35, given the dielectric constant of the medium is 2.6, we want to find the velocity factor, that is x. Here velocity factor is equals to 1 upon under root dielectric constant k is equals to 1 upon under root 2.6, that is 0.62. So option 2 is correct option. In question number 36, a radar has a power of 1 kilowatt and it is operating at frequency of 10 gigahertz. It is located on a mountain top of height 500 meter. We want to find the maximum distance, let's say that is d, up to which it can detect object located on the surface of Earth. This is top of the antenna. At this point it is located. So this d is the maximum distance up to which it can detect the object. This perpendicular is the radius of Earth. We can use Pythagoras theorem. So h plus r whole square is equals to d square plus r square. So h square plus r square plus 2hr is equals to d square plus r square. So d square will be h square plus 2hr. As h is very less than r, we can ignore this term. So d square is equals to 2hr. That is equals to 2 into height is 500 meter into 6400 into 10 power 3 meter. Simplify this, we will get d is equals to 80 kilometer. So option 1 is correct option. In question number 37, we want to find the maximum distance between the transmitting and receiving TV tower. The heights of both transmitting and receiving towers are doubled. Then what will be the maximum distance? Here d is given by under root 2r into height of transmitter plus under root 2r into height of receiver. Now height of transmitter and receiver both are doubled. Let's say maximum distance is d dash, so it will be 2r into 2ht plus under root 2r into 2hr. So d dash will be equal to root 2 into under root 2rht plus under root 2rhr. So d dash will be equal to root 2 times d. So option 2 is correct option. In question number 38, a TV tower has a height of 10 meter. That is ht is equals to 10 meter in a region of average population density 100 pi per kilometer square. We want to find the number of people that can receive the transmission. Here the maximum range is given by under root 2r ht, as height of receiving antenna is considered 0. So dm will be equal to under root 2 into 64 into 10 power 5 into ht, that is 10 meter. So dm is equals to 8 root 2 into 10 power 3 meter. So the number of people that can receive the signal is equals to 100 pi per kilometer square into area, that is pi r square. So 100 pi into 8 root 2 into 10 power 3. This will be approximately 128,000. So option 1 is correct option. In question number 39, a TV signal have a bandwidth of 6 megahertz. We want to find the number of TV channels that can be accommodated in a bandwidth of 12 gigahertz. Here, one channel requires 6 megahertz. That means 6 megahertz bandwidth can accommodate one channel. So 12 gigahertz can accommodate n channels, and n is equals to 12 into 10 power 9 divided by 6 into 10 power 6, that is equal to 2000. So option 4 is correct option. In question number 40, a message signal square wave is given. The amplitude of message signal is 1 volt and the carrier wave amplitude AC is 2 volt. We want to find the modulation index. Modulation index mu is given by AM by AC, that is 1 by 2, that is equals to 0.5. So option 3 is correct option. In question number 41, FC and FM are the frequencies of carrier wave and signal wave respectively. We want to find the bandwidth of the signal. The bandwidth is given by USB minus LSB. The USB is FC plus FM and lower side band is FC minus FM. So the bandwidth will be 2 FM. So option 2 is correct option. In question number 42, we want to represent depth of modulation in terms of Emax and E minimum. Here modulation index or depth of modulation is given by AM upon AC, that is EM upon EC. Emax is equals to AC plus AM and E minimum is equals to AC minus AM. Adding this two, we will get E max plus E minimum is equals to 2AC, and subtracting this two, we will get E max minus E minimum is equals to 2AM. Equation 1 and equation 2. Taking the ratio of 1 and 2, we will get AM by AC, that is equals to mu, that is E max minus E min upon E maximum plus E minimum. So option 3 is correct option. In question number 43, Vc is the amplitude of carrier wave in AM transmitter. M is the modulation factor. We want to find the amplitude of sidebands. Here, the amplitude of maximum frequency is AC and amplitude of USB and LSB are MAC by 2. So in this case, it will be MVC by 2. So option 2 is correct option. In question number 44, it is given that a carrier wave has amplitude of 10 millivolt. It is modulated by an audio signal of amplitude AM is equals to 2 millivolt. We want to find the amplitude of LSF or USF. The amplitude of LSF or USF is given by MAC by 2 and modulation index is given by AM by AC. Put this value in this equation. This will be AM by 2, that is equals to 1 millivolt. So option 3 is correct option. In question number 45, the modulating signal m of t is given by 2 cos of 2 pi fmt and the carrier wave is given by AC cos of 2 pi fct. We want to find which of the following is a conventional AM signal without overmodulation. So for reducing overmodulation chances, we should have modulation index that is equal to AM by AC should be less than 1. So here AM is 2 divided by AC should be less than 1. Among the given 4 options, the third option of x of t is equals to AC cos of 2 pi fct plus AC by 4 m of t cos of 2 pi fct has the modulation index less than 1. So option 3 is correct option. Thank you.